Page 16 of Applications of Calculus, we are finding the areas between these boundaries still. So we have this function, we have the x-axis, and we have the left boundary as 1 and the right boundary as 2. Let's graph this to see what it looks like. Y equals x cubed minus 4x graph. Okay, so between 1 and 2, that would be between here and here. So it's this part that's under the x-axis. So it would look something like one to 2. So it's like this part here. This would be 1. This would be 2. So it would be the integral from 1 to 2 of, and this is below the x-axis. So I'm going to do it's going to be 0 because it's below the x-axis. So the top curve is going to be the x-axis itself, which would be y equals 0 minus x cubed minus 4x dx. Let me simplify this. So the integral from 1 to 2 of negative x cubed plus 4x dx. So I'm going to take the integral of the inside. It would be negative x to the 4th over 4 plus 4x squared over 2. Bracket 1 to 2. So I'm just going to simplify 4 over 2 x squared. That's going to be 2x squared, right? Okay, so now we're going to substitute in the 2, we're going to substitute in the 1, and we're going to subtract the results, right? So negative 2 to the 4th over 4 plus 4 2 squared. Oh, I forgot. This is going to be 2x squared. So 2 times 2 squared minus negative 1 to the 4th over 4 plus 2 1 squared. So 2 to the 4th is 16, so negative 16 fourths plus 2 squared is 4 times 2 is 8. And I'm going to distribute the negative sign, so it would be positive 1/4, and then it would be negative 2, right? 2 times 1 squared is just 2. So I'm going to simplify negative 16 over 4 to negative 4. So that would be negative 4 plus 8, which is 4, plus 1/4, minus 2. So that would be 2 plus 1/4, which is 2.25. Okay. Next one. One arch of y equals sine squared and the x-axis. So y equals sine squared. Let's graph that. Sine x squared. The funny thing about sine x squared is it gives you another sine function. But it's like above the x-axis, because when you square things, everything's positive, right? So we just want one of these humps, one of these arches. So I just need to find this point here. This is obviously 0. Let's find this point. Second, calc 0. And so then I'll put the left boundary here, and I'll put the right boundary here, and we'll find when the arch touches the x-axis. Okay, that was a fail. Unfortunately, what happened was, since this touches the x-axis and goes back up, the calculator is incapable of finding this point because the calculator actually needs the thing to like get close to the x-axis and stay there for a second so that it can figure it out. So what we're going to do is we're going to use algebra. Okay, so we have a hump, and this hump is sine squared, right? Okay, so let's figure this point out. When does sine squared go back to 0? So we'll just set sine squared of x equal to 0. Sine squared of x equals 0, obviously if we square root both sides, we just get that sine x is equal to 0. So it turns out that sine squared x is equal to 0 when sine x is equal to 0. When is sine x equal to 0? Well, the first place at 0 is x equals 0. The second place at 0 is, what is it, pi. And the next point is 2 pi. So this point here, since it's the second point after 0 that it becomes 0, it must be pi. Okay, so it turns out that this limit is pi. So we're going to integrate sine squared from 0 to pi. And then so the integral of sine squared, do we know the integral of sine squared? Well, we do know an identity for sine squared. Sine squared x can be written like, the problem is we can't take the integral of multiplication, right? So we need to rewrite sine squared as another function. I don't know if you remember that cosine 2x is actually equal to 1 minus 2 sine squared x, right? Because of that, we can rearrange this so that we have sine squared x on the left. We could divide both sides by 1/2. So we could have sine squared x is equal to 1/2 minus 1/2 cosine 2x. If you ever have this on the IB exam, they'll give you a hint. They'll give you something like this so that you'll know how to rewrite it. 1/2 minus 1/2 cosine 2x dx. Now I'm going to take the integral of both 1/2, which would be 1/2 x, and I'm going to take the integral of negative 1/2 cosine 2x. It would be negative 1/2 sine 2x over 2. Yeah, because the integral of cosine is sine, right? The negative 1/2 coefficient stays. And then I put the 2 on the bottom to make the correction for the chain rule. Okay, now I'm almost done. So now I'm going to substitute in the pi and substitute in the 0 and subtract the results. So 1/2 pi minus 1/4 sine 2 pi minus, and then I'm going to put 0 in. So 0 minus 1/2. What's sine of 0? It's 0 also. Oh, so everything's 0 for that one. So I have 1/2 pi. What is sine of 2 pi again? Sine of 2 pi is 0. So the answer is 1/2 pi. Okay, number 3. Consider the graphs of y equals x minus 3 and y equals x squared minus 3x. Sketch the graphs on the same set of axes, etc., etc. Let's draw axes, and then we will use the calculator to draw these two functions. So the top function, well, I don't know which one's the top and which one's the bottom. I'll just put them in the order they gave it to us. X minus 3 is 1, that's linear. X squared minus 3x, that's a parabola. It's a parabola that opens up. What do these look like together? So there's the line. Y-intercept negative 3, slope of 1. Here's the parabola. X squared minus 3x. Okay, sketch the graphs on the same set of axes. Okay, find the coordinates of the points where the graphs meet. Did I do something wrong? Oh, x squared minus 3x. Oops. Okay, find the coordinates where the graphs meet. How would you do this without the calculator? You would set x minus 3 equal to x squared minus 3x. You would put everything on one side. It would be equal to 0, and you would solve using quadratic formula or factoring or something. So this point is obviously 3, 0, but what's this point here? Second calc 0, no, not 0, intersect, enter, enter, enter. 1, negative 2. Okay, so one of the intersection points is 1, negative 2, and the other intersection point is 3, 0. So we want to find the points where, okay, we found the points where they meet. Find the area of the region enclosed by the two graphs. That would be this region here. So we're going to do that by integrating between 1 and 3. And we're going to have the top function, which is the line, minus the bottom function, which is the parabola. And then dx. So, we should simplify this first. Combine like terms. X, positive 3x, right? If we distribute the negative sign, this will be negative, and this will be positive, and this will be positive. So x can be added to 3x, so that would be 4x. Negative 3 stays by itself, and then x squared is by itself. Okay, now we just need to integrate each one of these terms, so it would be, we actually take the integral, so we don't need the integral symbol anymore. 4x, the integral is x squared, 4x squared over 2, minus 3x minus x cubed over 3, bracket 1 to 3. So now we're going to substitute the 3 in, we're going to substitute the 1 in, we're going to subtract everything. So we'll put the 3 in, so this would be 2x squared. So that would be 3 squared minus 3 times 3 minus 3 cubed over 3, which would be 9, because it's 27 divided by 3, right? And then we're going to subtract everything with 1 plugged in. So it would be 2 times 1 squared minus 3 times 1 minus 1/3. So if we distribute the negative sign, it would be negative, positive, positive. 2 times 3 squared is 18. 3 times 3 is 9. Another minus 9. Minus 2 plus 3 plus 1/3. So that would be, 18 minus 9 cancels out. Negative 2 plus 3 is 1. And 1 plus 1, this is 1. And 1 plus 1/3 is 4/3. So the answer is 4/3. Okay, determine the area of the region enclosed by y equals square root of x and y equals x squared. We actually know how to graph both of these without using the calculator, so we'll just do that. Remember that x squared is just your parabola. Square root of x is a sideways parabola, one side only. So they intersect at 1, 1, right? If you put 1 here and 1 here, it works. If you put 1 here and 1 here, it works. It intersects at 1, 1 and 0, 0. The area of this region would be the integral from x equals 0 to x equals 1, and we'll put the top function, which is square root of x first, minus the bottom function, which is x squared. So first thing we're going to do is we're going to take the integral of the inside, so it would be x to the 1/2. We rewrote it there. We're going to do x to the 3/2 divided by 3/2. That's the integral. Integral of x squared is x cubed over 3. And then we're going to take the integral of the inside. By the way, 2/3 on the bottom is the same thing as, or 3/2 on the bottom is the same thing as 2/3 on top. So first thing I'm going to do, I'm just going to plug in, or I'm going to, I already took the integral. Did I already take the integral? I already took the integral. Oopsie. If I already took the integral, first of all, there's no more dx, because I already took the integral. So I'm going to have 0 and 1 here. I'm going to plug in the 1 into both, and then I'm going to plug 0 into both. I'm going to subtract the results. So it would be 2/3 times 1, because 1 to the 3/2 is just 1, minus 1 cubed is 1. Okay, and then I'm going to plug 0 into both. You just get 0. So basically it's 2/3 minus 1/3, which is 1/3. Isn't that weird? It's like these complex functions and the area is exactly 1/3, but in this little fish. Last one, on the same set of axes, draw the graphs of the functions y equals 2x and y equals 4x squared. Determine exactly the area of the region enclosed by these functions. Let's see if we can figure out where they intersect just by drawing the picture. So we have a line which goes through 0, 0 because the y-intercept is 0 and it has a slope of 2. There we go. And then we have y equals 4x squared, which is a parabola, which is stretched quite a bit so that it's very tall. Okay, so it crosses at 0, 0 and this point here. If we want to see what point it crosses at, we could just set the two functions equal to each other. And we can see that, oh, I see. Let's set everything, let's put 0 on one side and everything else on the other. And then we'll factor. Make sure we get all the solutions. Is that right? We should factor out an x too. Ugh. I'm going to factor out 2x from each. So the first term, after I factor out 2x, there would be 2x sobrando. And then if I factor out 2x from 2x, I would get 1 left over. So, and then if I wanted to see what the solutions are, when is this equal to 0? It will be equal to 0 either when x equals 0 or when x equals 1/2. So this must be x equals 1/2. Okay, so if we're going to find the area in this section here, we're going to take the integral from 0 to 1/2, and we're going to put the top function, which is the line, first, and then we're going to subtract, that's the first function, and the bottom function is the parabola. And we're going to take the integral of the inside. It would be 2x squared over 2, the 2's cancel, minus 4x cubed over 3, bracket 0 to 1/2. So we're going to plug in the 1/2, we're going to plug in the 0, and we're going to subtract the results. When we plug in the 0, everything becomes 0. So the only thing we really need to do is plug in the 1/2. 1/2 squared minus 4 1/2 cubed divided by 3, which is equal to 1/2 squared is 1/4. 4 times 1/2 cubed would be 4 divided by 8 divided by 3. So that would be 1 over 6. So 1/4 minus 1 over 6. 1 over 6. So that would be, let's see, we need to have a common denominator, which would be 12. 3/12 minus 2/12 is equal to 1/12. So our answer is 1/12. What a nice, neat answer. All right, that's it for this page.